Okay, so let's clean up the thing a little bit further. Okay, but before we do that, let's look at our code for a little bit. So I would like to take all this these classes, sprite and game app. I want to move it out of my main code. Okay, so but before we can do that, it will be more concrete if we add some more functionalities and to see if our library works fine, and then we try to extract that code. Okay, so let's move this to create sprite. Okay, I would like to add a new sprite. I want to show the monkey in our game, so let's do this self.monkey equals monkey. So it's just a monkey, and it doesn't move, right, for now. So let's make it just a sprite, and then self.canvas monkey.png, and then let it stay at this location, and then say self.sprite append self.monkey. Okay, so let's see if the game actually shows me the monkey. Okay, so here's the monkey. Okay, so it looks like it's kind of working. All right, so let's commit the thing first. Git commit -a show the player monkey. Okay, then just push it to the GitHub. All right, so now we're gonna take this code out. Okay, this game app and the sprite, but we can see that there's some issue here. So we have this canvas width and canvas height inside this game app, and also the update delay. Okay, so this is the constant that depends. This is for our game, just our game. So so we need to take it out, extract it out. So I would just add this to the constructor. So canvas width, canvas height, and then update delay here. So I just add the default here so that when we so it's easier to use a little bit. Okay, so let's do that, and then say self.canvas width, self.canvas height equals canvas height, and then self.update delay. And then now here just put in self.canvas width and self.canvas height, and then here and also the update delay. Okay, and when you create the class monkey game, just put it in canvas width, canvas height, and then update delay. Okay, so now I can just take this class out. Okay, so let's create a new file, gamelib. Let's call it just gamelib.py. Simple as that. Okay, and then I just remove this thing out. Gamelib, and gamelib also use tkinter. Just put it there. Okay, now we don't need tkk, I guess. We still need tk because it's this root thing. We'll clean it up soon, but let's say our code now only has the banana and monkey game, okay? And then everything is in game lib. Okay, so let's call it. Let's try to see if it run. Oh, crash. Oh, doesn't have sprite. So we need to import the sprite and game app from game lib. Import sprite and game app. Okay. Monkey game doesn't have canvas width. Oh, okay. So we add in this parameter before we call create canvas before we save the canvas width and height. Okay, so that's the error. Okay, so now let's see. Okay, everything works. Okay, just fine. All right. So that's we move our code out, and let's see if everything looks okay. So now there's something a little bit stupid here. Self.canvas. Okay. On the game app. Okay. If you look at the game app, we have, when we make sure that when we want everything to work together, so we need to somehow understand the interface between classes. Like if you want to use a game app, you have to make sure that you put all the sprite in self.sprites. So that's the interface, right? That's how the classes know how to work with each other. And this canvas. So this is fine. Okay, it's okay to have a sprite. I think that would be fine. But here, when you want to create a sprite, you need to pass the canvas. That's look kind of strange because the canvas is kind of like the concept from the TK inter. So I would like to encapsulate it a little bit further. So I would just add so my sprite class, I would update it a little bit here. So instead of taking the canvas itself, it would just take the game app. Game app here, and then the canvas will be taken from game app dot get canvas. You can do that, or just canvas. Okay, and then this game app should have the canvas with it. Okay, but when we use the sprite, we probably we're not gonna see it. Okay, and here so it should provide a canvas. Okay, so before you init the game, so you need to have the canvas ready. Okay, so that's the thing. Now I'm not gonna add the self.canvas. I just create a sprite with the game app, which is myself. Okay, so now would be I would be the game app. So let's see if thing works. Okay, so now you can remember it more clearly now. So if you want to have a sprite, so you need to create it with the game app. Okay, later on we're gonna have something called the parent, but for now let's call it we pass the game app, and then the image file name and the location. Okay, and then we can say set speed, and okay, so things looks fine now. We don't see any canvas. We still need to clean up the root thing here, but we'll do that later. Okay, so let's commit. Okay. Now, when you have so we need to add init.py gamelib.py. So I create this init.py so that we know that this is a module folder. It's an empty file. Okay, and then we have this py cache thing. It's gonna be the cache of the we shouldn't put it in our code repository, so we need to use this dot git ignore. Let's see. Dot git ignore. So you put everything you don't want to be included in the repository here. So this is called py cache. Okay, Now it's gone. Okay, you're not gonna see the py cache, but then you need to add .git ignore. Okay, so let's commit -a. So extract game app and sprite to game lib. Okay, so that's the thing. Okay, all right, so our game library looks a little bit more, a little bit nicer. Okay, when you work on the monkey, you don't have to look at a bunch of TK inter stuff, right? You can just look at this. Okay, we'll work a little bit more on how to make our game framework more flexible. We can say like we want the banana to stop, spinning, or maybe we want to hide the banana and we want to read the keyboard. So that's the whole thing. Okay, so we'll keep modifying the game lib so that it's more suitable to us. Okay, all right, so but before that, let's have a quick recap on the Git thing. Okay, so so what we've done so far is that we use basic git command. We call git init to create a repository, and we add stuff. Okay, Git doesn't track the file, it tracks the content. So if you want to add something, you need to say git add. Okay, then you need to commit. To save it to the snapshot, you can call commit /a. That would be take everything automatically. You can commit /m with the message. You can commit /am, that's the a and m. When you write the commit message, try to make sure that you understand it. There are many ways to write a good commit message. We will look at that later, but today just try to make sure that you understand what you're doing. Okay, you can, on GitHub, you can have issues. We have issues so that we can manage the project. Okay, and you can refer to the issue using the sharp1. So that's the tag, and you can resolve the issue by having something like resolve on the commit message. Then GitHub would automatically close the issue for you. Okay, so that's basically the quick command of Git. Okay, so now I'm gonna teach you. So suppose now we wanna work with more than one. Suppose we have a team with more than one people. Okay, so you work with your friend. How would you do that with Git? Okay, so let's see some example. So this is my GitHub. So this is me. Okay, and this is my other me. This is the monkey GitHub. Okay, I would like to add him to that guy to my project. So what we would do, there are many ways to do that. People on GitHub usually refer to this as workflows. Okay, we'll use the simplest one for now. Okay, so so let me add git.f to this this repository, monkey demo. So invite collaborator. So it's called git.f. Okay, add git.f to the repository. Okay, then on that me here, then I need to there will be an email sending to me. So the invitation look like this. So I just hit new invitation and accept it. After I accept that, I am on this, also on this monkey demo. Okay, so now I can work on the same repository with git.f, and git works on the same repository. So you're gonna have the same remote repository. Okay, and thing will be a little bit more complicated with that. Okay, so let me explain you the concept of branching and how to work with your friend. Okay, So let's look at our example. Okay, so you have GitHub here. This is GitHub. Okay, and you have 2 local machine. So that's GitHub, and another is monkey GitHub. So this is the monkey one. Okay, and we have this repository at GitHub. Okay, so when you look at the repository like that, so you have a local here. This guy, okay, gonna have a local repository, and we have remote. Okay, and the remote would you can have many remote. Okay, but one remote points to GitHub. Okay, here this guy also have local and remote. Okay. Okay, so the local, if you remember, there's a branch called main. There's a branch also called main here. A branch is something I'll explain later on, and it also track the remote branch at GitHub. Okay, so this is remote, so it's called main as well. So remote is called let's see. Okay, so you can call git branch. You say the branch that you have, it's the git main, right? So if you say git branch /a, it will give you all the branch that you have, including the remote branch. If you say git branch /r, that's the you see only the remote. But if you say git branch /a, you have this remote origin main. Okay, so origin is here. So here, so there are many remotes, right? So the remote is origin and has a branch main. Same thing here. So remote has the host called the target is origin, and then there has a branch main here. Okay, so that's how things look. And here at GitHub, you have only one branch called main. Okay. What is the branch look like? So if you have a Git repository, you can see if you call git tk, this is a history of your thing. Okay, so currently we have we start with this commit, and then we have a series of commits, and it's look pretty much linear. Okay, so let's see some picture like this. Okay, so at this point, .f, this monkey .hut has just arrived, right? So but previously if you call git k, okay, that would show the graph, and the graph go from bottom to the top. But now let me write from left to right for now. Okay, so these are the commits. Okay, and initialize, and then the commit would look like that. You can think of this as a linked list, but it's not going to be a linked list anymore later on. Okay, and this is the head. Okay, and every time you push to GitHub, you just take everything here to GitHub. So let me put some number 1, 2, 3. Doesn't have to be the consecutive number, but let's do it this way for now. So on GitHub you have this as well. Okay, and what we call main. Okay, main is just the pointer to somewhere in the repository. So this is main. In GitHub there's a pointer called main here. Okay, like that. Now this new guy, when the monkey .hut would like to work on this repository, he has to clone it. Okay, and then he would get something like this. He has a version of this locally as well. So now suppose that the original .hut works on some other improvement, so he can make a commit that would be called 7 here, and then when he pushed the thing to GitHub, then you're gonna get something like this. So when this guy commit, you end up like this, and then this is commit. Let me write it. Commit. And then when you say push, okay, so the new thing would appear here. And the head also move, right? So let me throw away the head for now. And main would change to that. Okay. So Git F, after the push, it's appear like this. Git F, if he would like to continue working on the new stuff, he can say fetch. So the simplest one to do is to call pull. Okay, you have pull and push. When you do pull, every changes on the server will be pulled to this repository. Inside pull, there are two steps called fetch and merge. We will see that later on. Okay, so 7 is here. 7. Okay, and this is called main. Okay, now it can be the case that before I do the pull, Git F also make a change. So this is the simplest one. It's pretty much linear. Okay, this guy it push to the repository, and this guy also pull it back and then start working. But things is not gonna be that way, right? So it turns out that maybe Git also work on something and commit to the repository as well. Okay, so thing would look like that. Before he do the pull, he also work on the repository and make a commit. Okay, so let's call this commit 10. Okay, I'm not gonna follow the number anymore. Okay, so he commit, and then now he would like to push. So this is his main branch. Okay, he would like to push the thing to the repository as well, right? I want to push, but he cannot do that because the main branch here and his thing is here, right? There's conflict here. You cannot just push the thing to the server. To do that, you can forcefully do that, but then you break the repository, and if you do that, you're gonna break the main branch. Okay, the only way you can push safely is to do the fast forward push. Okay, everything like contains in the previous push, but you cannot do that now. Okay, so it breaks. You cannot do that. Okay, so Git F, he has to do the pull first. When he pulls the thing, okay, what would appear is that 7, this chain set, will be pulled to his local machine. Okay, let me show you how things gonna. So you're gonna have 7 here. Here. I'm gonna show you on the code on the terminal soon. Okay, but let's look at it for now. Okay, so but 7 is from 6, so you're gonna have the history that look like that, and then now you have two heads now. So 2 heads, this one and this one. Okay, when you do pull, the Git would take all the change and try to merge the thing for you. Okay, so 7 and 10 will be merged, and you're gonna get something. If there's nothing wrong, hopefully what you would get is that Git would do this for you. Okay, so they'll try to merge the thing into this commit. Okay, when you do the pull, if there's no conflicts, then it would merge for you. Okay, and then you get the new commit here called 13, and from that and then everything should work fine. But if there's a conflict, then you need to fix it. Okay, we will show you example on that. And then now you can push. Okay, when you do the push here, if everything works fine, what you would get on the remote side would look like, I'm gonna have 10 here, sorry, 10, 13, and the main branch should be here. Okay, now if the original Titat would like to pull, he will get the whole thing. You get this whole thing to his local. Okay, so that's how things work when everything went smoothly. There's nothing. We didn't have to do branching for now, but this is how things supposed to work in your dream. Okay, I ideally, okay, but it won't be as smooth as this. Okay, but let's see how things work in the actual code. Okay, and then we'll learn why we need to work on branching. Okay, so let's see. Okay, so let me clone another monkey. So we have two users, recall that. So this is the other one. Okay, so the white terminal is the original Titat, and this is the monkey Titat. Okay, so I'm gonna clone it, git clone. But then I need to make sure that I get the actual user, right? Not just the other user. But I need to make sure that I get the real user, not this. Okay, so I clone it. No, sorry. So this is another user. Okay, so let's try to fix it. Change a little bit on the original thing. So let's move the monkey, the first monkey, for a bit. So let's say at location 50. And try to commit it. Okay, so it's there, so just commit. So I'm not gonna okay, move the monkey. Okay, now the other guys should do something too. So let me use Emacs on here, so that is different. Okay, so the first guy used VS Code, this guy used Emacs. Okay, monkeys. So let's add another monkey. Okay, so let's add another monkey. So let's put it there. Okay, save dot. Let's call it enemy sprite. Sales. Use the same monkey for now, and then put it in say 7. Okay. Pen enemy. sorry, enemy, self.enemy. Okay, so let's run this one. Okay, so it moved a little bit, and let's run this one. Then you have 2 monkeys. Okay, so we have already commit the original one, so let's commit here. Another monkey, enemy. Okay, so now I would like to push this this thing. Okay, so let's push let push this thing first. Git push. Okay, I have already logged in, so it looks like that. Okay, so let's call git push. Okay, so this is the other user. Okay, my password. What's my password? And it say it's rejected because it's not non-fast forward, because there the other guy has already pushed the thing. So now I cannot push because it's on the same branch, and you can only move forward on the same branch. So to resolve that, I need to call git pull. But git pull, inside git pull is called git fetch and merge. But let's try to do git pull for now. Okay. So it's pull everything, and it say there's a conflict. Okay. And automatic merge fail. Okay. So what exactly is the conflicts? Let's see. Okay, it shows that the previous code, okay, here this is the head, and this is my code, right? And this is the other guy code, and it's there's a conflict. Okay, I should have give you an example without conflicts, but accidentally you cannot completely avoid the conflict. So it cannot merge for you. It shows you this, and then you need to decide for yourself how to merge. So let's do that. Okay, so the other guy moved the thing to here. If you work on the different places, then thing will be much nicer. But now let's say it's a conflict. Good. After I fix the conflicts, I try to run it one more time. Show the 2 monkey and the other one move. Okay, so if that's the case, then we need to commit. Okay, so on the commit message you should say merge, something like that, so that you know that there's a merge going on here. After you merge, then you can push now. Okay, now you can push the thing. If you go ahead and look at the network. Okay, so this is the picture. Okay, so let's see the code inside. Okay, you can see it here that here you have add another monkey, and then I have moved the monkey, and then there's a conflict, then I combine the merge here. Okay, so let's do it one more time, so that but now let's try to avoid the conflicts. Okay, so here I can just call git pull. This is my other user. This is the original user. So let's say it's in code here, right? So again, let me move the first monkey back to the same location. Okay, move monkey back. Okay, and then you do git push. Okay, but here this guy, let's do something else. Let's change the monkey name. Okay, monkey banana game. Let's do that. Okay, let's have the monkey banana game over there. Okay, on different line should be fine. Git commit. Change, rename the game title. Okay, now you cannot push again. Okay, now we can do the Git Pull, and then it will merge automatically because you have no conflicts, right? And it also do the merge, and then it commits the thing for you for you. Okay, here this is the merge and commit. Okay. Previously when I told you that so if it's already if there's no conflict, okay, it's gonna merge for you. Okay, but if there's a conflict, then you need to merge manually. Okay, if no conflict, auto. Okay, so pull do the fetch and merge. Okay, it merge automatically if there's no conflict. Okay, so you can look at the chart. You can see that it automatically merge, and then you can push back to the GitHub. Okay, so that's how thing works on a simple workflow. If you work on the same main branch, okay, but thing can get more complicated when you start working when you do something when you have a bigger project. Okay, all right, so let's have a quick recap. So you can have you can call when you have a remote repository, you call push and pull. Okay, you want to push something, you call git push. You want to take something, you call git pull. Inside git pull, there are two steps. One is git fetch, that would take all the change and the commits, and then try to do the merge. If there's no conflict, it will perform an auto merge and commit the merge commit for you. But if there's a conflict, you end up with the broken source code, and then you need to do the manual merge. You need to sort things out, and then you need to commit. Okay, and when things works, everything works. But when thing doesn't work, these commands are probably useful. You can use Git Log to see the commits. You can do the Git checked out to switch the current location on the change set, and you can do Git reset. Okay, so but Git reset is like you clean up stuff, and then you clean up all the change set. It's really it's a very dangerous command, so don't use it unless you are really careful. Okay, and you can view your repository. I have Git K, but you can have your local Git client so that you can look at how things works. Okay, so let me show you a few steps, few things. So you call Git Log. Okay, you can see all the stuff, right? These are the commits. You have this crazy numbers, okay, and it says this is the merge from this and that. You can see stuff like that. Okay, you can if you want to do some traveling, you can just say check out this, checked out, and put the repository here, and then you are at this point. Okay, and the code will be you can see that you back to this this location. But then if you commit thing, you create commits that has no head. Okay, so it gives you a warning here. You're in a detached head. You can look around and then, but what you save here is not going to be belongs to any branch. It can be gone. Blah 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 blah. Okay, you can go back to main. Okay, you can see you're here. Okay, but if you call git reset, the history will be kind of like gone. So be careful, unless you make a really crazy mistake and you want to move here and then you do the reset, then that would be fine. I'm not gonna show it for you. You can mostly you can do checked out and it would be fine. But if you are in the middle of the merge, okay, and you want to move, then the thing can be really bad, because when you move, the change that you already have is gonna be gone, right? So you can end up in a, you know, everything is gone, so that's gonna be bad. Okay, to do that, if you're in the middle of the merge, make sure you get things done before you move. Okay, this is there's another trick called git stash. Okay, it would basically, if you in the middle of something, git stash would save your status, and then so that you can come back and work on the thing later. You can Google it. Okay, you can call git stash and git stash apply. But basically, if you are in the middle of the merge, try to get it done. Okay, otherwise you need you know, it's going to be a long work. Okay, so be careful. Okay, if you have a really crazy merge. Okay, so typically people don't want to do crazy merge that often. Okay, so so let's look at the details on that. That's why people work in branch and try to sync more often. Okay, so okay, so let's look at another situation when there are two people working together. Again, so this is the GitHub and this is the monkey GitHub, and you have GitHub here. Can be the case that you have a history that look like that, and then this guy made is in the middle of something. Okay, and but at this point, this change is still called a breaking change. Okay, so the code doesn't run. Maybe you in the middle of something, you need to clean up so many modules, but he need to check out. Okay, so if you work on that, and then this guy also working on something else, but this change is good in the sense that people can still use the whole thing. Okay, now when you push the thing to GitHub, you need to sort things out, right? You need to merge them and so on, because if you have this as the main and this as the main, you can only have one branch of the name main, right, in GitHub. So you need to somehow merge them, and then, but after you merge, if this is a broken change and in the middle incomplete change, broken or incomplete change, then after the merge, this guy will be really mad because he cannot do any other things, right? So things can be really get really bad for that. Okay, so the way to deal with this is either this guy just do everything locally when things done and then just commit. Okay, choice one, do locally and then commit and push only when done. But then if there are many people working on this same thing, then you cannot collaborate, right? So so this might not work well. So choice 1. So choice 2 is to use branch. Okay, so instead of working on this main branch, he would create another branch called feature branch. This is gonna be main, and then he has this call a feature branch or whatever. The name of the branch should reflect what he works on. Okay, now when he push the thing, main will be the same, right, at GitHub. So here in GitHub, so when he push something, main would remain here, and this feature branch is gonna be also on GitHub on the remote repository. Okay, okay, sorry. Typically, you're gonna write the arrow backward to the parents, right? But I write in the wrong direction, so that it's look like a linked list. But never mind. Should be understandable. Okay. Now when this guy push the thing, so this push first, and then when this guy push, the main branch would look like this. Okay, so let me try to be more standardized. So I'm gonna write the arrow in the correct direction for later on now. Okay, so now when he do the pull, he would get this thing with him. Okay, so let me change the direction of the arrow for. Okay, all right, so now this guy knows the branch and see the update. Okay, so the guy working on the main branch can continue working on the stuff, and this guy working on the feature branch can also work on his own branch. Okay, now when everything is done, he can just merge later on, or maybe to make out his life a little bit easier is that you should merge often. Okay, so that's it. Later on, when he keep working on this, he want to make sure that you know, his branch is not very much divert from the main branch, so he can just do the merge here and put it in feature branch, so it's a quick touch point and he can keep working on the stuff. Okay, and this guy can also keep working on adding to main, so the main branch would keep going, and he could, you know, constantly sync with the main branch. This is how things should work. Okay, when everything is done, he can just merge everything, so the main branch keep point to this, and so on. And then when he get everything done, he can just do the merge finally and move the main branch to here. When everything is done, and he can just throw away the feature branch. Okay, when everything is done, things gonna look like this. So you're gonna have main branch, and you have feature branch, and finally they got combined like that. And also the feature branch can regularly check up with the main branch, so you can keep merge the main branch to the feature branch, so that when you do the final merge, things, it's not going to be that bad. Okay, so this is the feature branch. Okay, so that's the idea of feature branch. You at a particular time, you can have many feature branch on the same time, and the main branch would basically track the bug fix and everything. So you have this is the change set, and then you have the other branch. This is the feature branch, first feature branch, and the second feature branch may start here. The feature branch should regularly checked up with the main branch, and then when the feature branch is done, it got merged to the main branch, and now you have a main branch, like continue on that, and the orange branch. When the orange feature is done, then you do the merge again, then you're done like that. So that's how things should look. You can have also inside a branch, you can have also feature branch inside a feature branch, and so on. So this these two things, this people many people might not do that, but if you keep the feature branch somehow in sync with the main branch, it will be much easier when you do the merge at the end. Okay, so that's how things look. Okay, so this is the main branch, and if feature one, this is feature one. Okay, so this is the idea. So let's go ahead and see what's happening in with the real code. I'm gonna recap you with the command line later on. Okay,